Welcome to Engineer Legends. So in this video, we're going to look on partial differentiation in multivariable calculus. So what do we have today? So what we need to differentiate this function with respect to y. So that means we have to find partial f, partial y. That's what we need to do. As you can see, we have some fractions here and I hate fractions because we have to apply some quotient rule. So what I'm going to do, I'm going to make this a linear function, right? So if we have 1 over 2, it's same as 2 to the power negative 1. 1 over something is just simply the inverse of that thing, right? Okay. And right here, we have y over x. But you know that if we want to differentiate a linear function, we'll say the derivative of that function divided by the original function. So I'm going to raise x right here. On this one, I'm going to do nothing. Since we have x, it's going to be 0. It is going to become a constant, right? Okay. So now let me arrange here. I'm going to say x plus y to the power negative 1, and this x is going to become x to the power negative 1. Okay, so let's do that. If we do that, this is what we're going to get, right? Okay, but as you can see, we can still arrange right here. If we have ln x to the power negative 1, we can drop the power, right, and the power can come right here. That's the advantage of using logarithms. Okay, so let's drop the power. So this is what we're going to get. Now we're going to differentiate with respect to y. This one is going to become 0. Y, we don't have any y constant right here. What about here? So the derivative of this with respect to y. So x is just a constant. If we differentiate y with respect to y, it's going to become 1. So we're going to be left with x to the power negative 1. What about here? So the derivative of this function with respect to y, if we differentiate x plus y, x is going to become 0 and y is going to become 1. So right, we're going to have 1 over the original function, not forgetting our negative right here. And in this case, we're going to have x to the power negative 1 over original function, and this one is going to become 0. Okay, so this is what we're going to get, right? And you can see, you can cancel right here. This is x to the power negative 1 divided by x to the power negative 1. Yes, we can cancel this one. Okay, so if we do that, this is the answer that we're going to get. Thank you for watching.